Welcome to this class. Today I am continuing the chapter Pressure of the subject Science and Technology of class 10, and it is taken in the unit number 8. And we have divided this pressure chapter into different parts, 7 parts, and we are presenting one after another, and this is 5th part of the chapter Pressure. Today we are going to focus on the factors affecting the upthrust. First, we have to understand, we have to recall the upthrust, and then we'll go through factors affecting the upthrust. Okay, let's start. Upthrust. What is upthrust? Let's have a diagram, the animated diagram. With the help of this animated diagram, I want to tell you what exactly is upthrust. Let's say water is taken in a container and a piece of wood is placed in it. But what do you think? Will it go down? No, it won't go down. It flows on the liquid. And if we place it down up to the bottom of the water, then what is found? When we release our hand, then it comes up again. What is happening? If we push this wooden piece again downward, again water pushes it up. What is happening here? Exactly what is happening? This wooden piece is pushed by water in the vertically upward direction. And this force of pushing of water in the vertically upward direction is named as upthrust. And because of upthrust, this piece of wood doesn't sink, it comes to the surface. And so we can define upthrust this way: a resultant force acting vertically upward on a body when placed in a liquid is called upthrust or buoyant force. Its SI unit is Newton. Since it is force, that's why it is measured in Newton. Have you noticed this? This resultant force is told. Why? The reason is very simple. When a body is placed in the liquid, then the liquid applies force from all the directions. And resultant of all these forces acts in the vertically upward direction, and this term is named as upthrust or buoyant force. Okay, why don't we do this practically? I want to show you with the help of one activity. Let's feel upthrust with this activity. Look at this is Theki, and this is actually the model of Theki. The Theki is bigger in size. This is the model only, and this is the lid of Theki. It is made of wood, and I want to use this lid in this activity. When we put this lid of Theki in this water, then what is seen? It is floating. If I press it down, then it goes down because I am applying force. But when I release my hand, it comes up. What it means? It means water is pushing it upward. By force, it can be pressed to the bottom of the water, but again it comes to the surface. This is the experience of what? Upthrust. This water is pushing the body in the vertically upward direction. We have to be clear that it won't push towards forward direction or backward or in the sides. It pushes the body in the vertically upward direction. That's why resultant force which acts on this body in the vertically upward direction is called upthrust. Now let's have another mass also. This is one of the standard mass. It is of 40 gram. This 40 gram mass made up of steel is, if placed in water, then it goes down. What the reason? At this time upthrust is not acting on this body. Upthrust is acting on this wooden piece only. It won't act on this steel piece. No, this is wrong idea. Upthrust is acting on this steel piece also, but here we have two forces. One is downward force, that is the weight of the body, and another is upward force, that is upthrust. If upthrust is less than weight, then certainly the body sink in liquid. But upthrust, in this case, upthrust is sufficient to support the weight of the body. That's why the body is floating. In this case, upthrust supports the body weight. That's why it is floating. But in this case, upthrust cannot support the weight of the body. Weight is very high, and off thrust is less, that's why it goes down. Okay, now how to measure the off thrust exerted by a liquid on a body? If we have a stone, a piece of a stone, it is placed in water, certainly we know that it sinks in water. And even though the off thrust is acting on the stone, then how to measure off thrust exerted by the liquid on a body when the body is placed in the liquid? Now I want to go through the measurement of off thrust. Look at this. Measurement of off thrust. For this, I want to show with the help of animated picture. This is a vessel which is partially filled with water, and let's say we have a body and we are going to take its weight in air. Weight of the body in air is, let's say, 10 Newton. Now I am going to immerse this body into water. When it is immersed in water, do you think that its weight remains 10 Newton again? No. Just before this, I told you that water exerts an upward force on the body. This force is acting against the weight of the body. If a force is acting vertically upward against the weight of the body, certainly weight of the body reduces. And it won't remain 10 Newton because of this off thrust. And now its weight is reduced. Let's say its weight is 9 Newton only. Now we have one information. Weight of a body in air is more. Weight of the body in water is less because of what? Off thrust. Now what amount of weight is reduced here? 1 Newton. And this 1 Newton is off thrust. So we can say that off thrust is equal to weight of the body in air minus weight of the body in liquid. What an easy matter. If we have to find the off thrust acting on a body, then just take its weight in air and again take its weight in water. Difference of weight is off thrust. That's why if you have to find off thrust acting on a body, then first its weight should be taken in air, and secondly its weight should be taken in liquid. The difference of weight gives us off thrust. And symbolically we can say that U is equal to weight in air minus weight in liquid. And in this case, particularly in this case, weight in air is 10 Newton, weight in water is 9 Newton. That's why off thrust can be calculated easily as 1 Newton. It's very simple. Why don't we do this practically? I want to show with one activity that off thrust exerted by water reduces its weight. Okay, look at this. A standard mass is taken and its weight is being measured by the use of this spring balance. Weight of this body is shown in the spring balance. It is 0.4 Newton. Yes. Now I am going to immerse this into water. Now what happens next? Look at this. When it is immersed in water, now have you seen this? Its weight is now decreased. No more 0.4 Newton. It is less than 0.4 Newton. It is nearly 0.3 Newton or 0.32, something like this. This way we can understand very easily that a body weighs more in air but the same weighs less in water because of the off thrust. Because of off thrust, weight becomes less in liquid than that of air. Now I think you are clear about off thrust. What is off thrust? This is vertically upward force exerted by a liquid when body is placed in the liquid. And how to measure off thrust? Off thrust can be measured very easily by weighing the body in air. Again, weighing the same body in liquid because difference of weight is off thrust. After this, now let's have the factors affecting the off thrust. What are the factors which affects the off thrust? What are the factors on which off thrust depends? Okay, let's start. The first factor on which off thrust depend is, this is the prime factor, weight of displaced liquid. What it mean? Weight of displaced liquid is, if more, then off thrust will be more, and weight of displaced liquid is if less, then off thrust will be less. It can be understood very nicely with the help of this diagrammatic representation. Let's say we have a vessel and a piece of iron is placed in it. certainly it sink because its density is greater than water. And it sink in water. And in the same way, another piece of iron is also taken, but its size is small. It also sink in water because density of iron is greater than water. That's why whether the piece is bigger or smaller, it doesn't make any difference. They will sink in water, certainly. And both of them experience upthrust. We know about this because just before this I told you about the upthrust. Both of them experience upthrust, but the value of upthrust is different. In this case, in first case, the volume of the body is more. That's why it displaces more amount of water. We can show it with the help of this. Look at this. According to its size, let's say it displaces the water of volume this much. And the second one displaces less amount of water because its volume is less. And the water, which is equal to its volume, it displaces the same volume of water which is less than the first. Now certainly, weight of this much amount of water is more than this much amount of water. So the first body experiences more upthrust equal to the weight of displaced this much amount of liquid. It may be, let's say, 2 Newton. But since the weight of displaced liquid in second case is less, and let's say it is just 0.5 Newton, then it experiences 0.5 Newton upthrust. Both of them are sinking in water, but because of weight of displaced water, first one experiences more upthrust, second one experiences less upthrust because weight of displaced water is more in case of first than that of second. Okay, that's why we can conclude that first one experiences more upthrust, second one experiences less upthrust. Now, let's go to another factor which affects the upthrust. First factor, what was it? Weight of displaced liquid. If a body displaces more amount of liquid, then upthrust will be more, and less amount of liquid is displaced, then upthrust will be less. Okay, now next point. Upthrust depends upon density of the liquid. Very interesting. Again, I want to show some diagrammatic representation. Look at this. This is water, let's say. And another vessel, identical vessel, which contains saturated solution of salt. Saturated solution, do you remember what is it? You are taught in class 9. What is saturated solution? If a solution cannot dissolve any more solute, then that solution is called saturated solution of that temperature. We are taking saturated solution of salt. It means at this temperature, what amount of salt is dissolved? If you want to dissolve more, that cannot be dissolved. If we add a little amount of salt here, then it cannot be dissolved. This is saturated. Okay. Now let's take an egg, and I want to put the egg in water. What do you think? What happens? If you don't know, this egg sink in water. Egg sink in water. If it is taken in water, then certainly it sink in water because its density is greater than the density of water. But if the same egg is taken in saturated solution of salt, then it won't go down. It won't sink into the saturated solution of salt. What is the reason? Reason is very simple. In this case, water exerts less amount of upthrust, which is not enough to support the weight of the egg. But in the saturated solution of salt, the salt solution exerts enough amount of what? Upthrust, which can support its weight. That's why the body is floating in the saturated solution of salt. The egg is floating. That's why the conclusion of this activity is upthrust depends upon density of the liquid. If a liquid is denser, then it exerts more upthrust. If a liquid is less dense, it will exert less upthrust. That's why water's density is less, that's why its upthrust is less, and the saturated solution of salt, its density is more, that's why it exerts more upthrust, so egg floats on saturated solution of salt. Let's have some other liquid also. This is salt solution. and this is pure water, and this is kerosene. Can you compare the density of these three liquids? Density of salt solution is more than pure water, and density of pure water is more than kerosene. We used to say that kerosene is lighter than water, but really we have to say that as a science student, we have to say that density of water is greater than kerosene oil. That's why kerosene is lighter than water. If we mix these two, then kerosene forms upper layer, water forms lower layer. The conclusion, what I am saying, salt solution is denser than pure water is denser than kerosene. Now, let's take a piece of iron. If we put the piece of iron in salt solution, certainly it sinks. And the piece of iron also sink in pure water and kerosene because its density is greater than salt solution, pure water, kerosene. Density of iron is about 8 gram per cubic centimeter, but density of water is only 1 gram per cubic centimeter, and salt solution its density is a little greater than pure water, and kerosene it is a little less than pure water. That's why the piece of iron sink in all these solution. But it experiences different upthrust in this different liquid. In case of salt solution, let's say it experiences upthrust A, symbolized by A, value of upthrust is A. In pure water, the value of upthrust is B, and in kerosene, the value of upthrust is C. If we compare the upthrust exerted by this liquid on the piece of iron, then what is found? A is greater than B and B is greater than C. Very interesting. A piece of iron experiences more upthrust in salt solution, a little less upthrust in pure water, and very less upthrust in kerosene oil. This way we can understand the density, relation of density with the upthrust. More dense the liquid, more will be the upthrust. Okay, let's go to another point. This upthrust depends upon volume of the body immersed into the liquid. Very interesting, new matter came. What? Volume of the body immersed into the liquid. This can be understood as volume of the displaced liquid. If volume of displaced liquid is more, or the volume of the body immersed into the liquid is more, then upthrust will be more. If volume of the body immersed into the liquid is less, then upthrust will be less. We can go through this animated diagram also. Look at this. This vessel contains water. If a body is weighed in air, we have to take a little long body which has greater length than that of the breadth and height. If it is weighed in air, let's say its weight is 10 Newton. Now I am going to immerse this into this water, but at first I want to immerse a little only, this one. Yeah, at this time certainly upthrust acts on the body, and the weight of the body reduces, and because of this upthrust, let's say its weight is reduced to 9 Newton. Now we can say that at this time upthrust is 1 Newton because 10 Newton was the weight and its weight in the water is 9 Newton. It means 1 Newton should be the upthrust. Now the same is taken again. Now I am going to immerse it a little more than the previous. Yes, a little more immersion. At this time what is found? Its weight is reduced by 2 Newton. Its final weight is now 8 Newton. Its weight in water is now 8 Newton. It means 2 Newton of thrust is acting on this body. Volume of the body immersed in the liquid is being increased, and increasing the volume of the body immersed into the liquid increases the upthrust also. So I want to go through another diagram also. Look at this. If the same body is immersed more than the previous, then what is found? Its weight decreased to 7 Newton. Let's say these values are imaginary but exact, not exact, but the same trend can be seen. The experiment can be done. I want to show this practically also. Look at this. Its weight is now 7 Newton. When the same body is immersed completely into the water, then what is seen? The weight becomes minimum. It is 6 Newton. It means 4 Newton of thrust is acting on the body. What is the conclusion of all these experiments? Conclusion is, of thrust depends upon volume of the body immersed into the liquid. If more volume is immersed, then of thrust will be more, and if less volume of the body is immersed, then of thrust will be less. Why don't we do practically? Let's go to practical. I'm going to take weight of this nail cutter. It is 0.48 Newton. It appears 0.48 Newton. Now I want to immerse this a little more and more in this liquid. Look at this. When it is immersed a little, then weight reduces a little because of thrust is little. When it is immersed a little more, then reduction of weight is more than the previous. Yes, and if it is completely immersed now, I think it is about equal to 0.4 Newton. It means weight is being less and less and less when we immerse it more and more in liquid. It means the of thrust depends on volume of the body immersed into the liquid. You can see again, look at this, less immersion, less of thrust, that's why reduction of weight is less. More immersion, more of thrust, reduction of weight will be more. This way we can practically understand that the volume of the body immersed into the liquid is one of the factors that affects what? Of thrust. Now let's conclude. After all these experimental and diagrammatic representation, we can conclude that what factors affects the of thrust? Weight of displaced liquid, and another density of the liquid, and another one volume of the body immersed into the liquid, which can also be told as volume of displaced liquid. After all these explanation about the factors which affects the of thrust, actually this first factor is the prime factor. Increase of density of the liquid increases the of thrust, means ultimately if a liquid has more density, then weight of displaced liquid will be more, and that's why this second point is also related to the first. And volume of the body immersed into the liquid is if more, then certainly weight of displaced liquid will be more. That's why all these other points are actually related to the first point. That's why we have to understand this very clearly, that actually the of thrust acting on a body depends only upon weight of displaced liquid. Okay, now let's have a question. After all these explanation, you are able to answer this question. Whether you are able to answer or not, I want to see it, and then I will answer this question. Okay, let's have a question. Weight of a body in air, water and salt solution is given below, but not in order. Don't think that it is given in order. Weight in air is not 40. No, weight in water is not told 42, and salt solution not 41 Newton. It is not in order. Weight of the body in air, water and salt solution is given below. Answer the following questions on the basis of the given value. Now, what is the question? Question number 1. Identify the weight of the body in air, water and salt solution among A, B and C. Give region. Look at this. We have to identify which one is air, which is water, which one is water and which one is salt among A, B and C, and we have to give region also. Now how to identify? Just think about this. Weight of the body is maximum 42 Newton, and weight of a body will be maximum when its weight is taken in air, because when we take the weight of the body in air, at this time also of thrust acts on the body, but of thrust is equal to weight of displaced air, since weight of air is negligible for that body. So the real weight of the body is taken as the weight of the body in air. So it is maximum. Weight of the body in air is maximum. So B must be what? B must be air. because weight is maximum in air. Now, what do you think about C and A? When the same body is immersed in water and salt solution, which one exert more of thrust, water or salt solution? Certainly, salt solution exert more of thrust because it is denser than water, and off thrust depends upon density of the liquid. More the density, more the off thrust. That's why in salt solution, its weight will be minimum. This is 40 Newton. A must be salt solution, C must be water. In both the salt solution and water, off thrust acts on the body, but off thrust is more in salt solution. That's why reduction of weight will be more in salt solution. So we can conclude that C is water, but A is salt solution, because in A we have minimum weight of the body. This way we can answer. Okay, now let's go to next question. What is the value of off thrust of salt solution? Value of off thrust. What do you think? What is the value of off thrust of salt solution? Which one is salt solution? A. And what is the value of off thrust in salt solution? Off thrust is equal to what? Weight of the body in air minus weight of the body in liquid. Weight of the body in air is 42 Newton and weight of the body in salt solution is 40. That's why 42 Newton minus 40 Newton becomes 2 Newton. 2 Newton should be the off thrust of salt solution. Clear? Now let's go to next question. Calculate the mass of the body. This is calculation. We are going to calculate the mass of the body, and we know that weight of the body is the product of its mass and acceleration due to gravity. It was taught in the chapter Force in Motion. Now I want to recall that, and I want to calculate the mass of the body. Weight of the body is equal to 42 Newton. Now we are asked to calculate mass of the body. Weight of the body in air should be taken because the mass can be calculated with the help of weight of the body in air. Now we have what we have, W equal to mg, because weight of a body is the product of its mass and acceleration due to gravity. And in place of weight I can write 42 Newton, and mass we are going to calculate g 9.8 meter per second square. It was taught in Force and Motion chapter, and 42 Newton is expanded form is kg meter per second square. It was taught in the same chapter, is equal to m. I want to take this 9.8 to left hand side and it goes in denominator. 9.8 meter per second square, meter per second square, meter per second square cancel. Therefore m is equal to, now we have to divide 42 by 9.8 and then we will get result. I am using calculator. 42 divided by 9.8, this is equal to 4.2857. 4.2857. 4.2857. Why to use all these number? After 2 digit we will ignore other number, but this is 5, that's why I want to add 1 to this 8. 4.29 kilogram. This is the mass of the body. Okay, we have calculated the mass of the body. Now let's go to another question. Calculate the mass of displaced water. Again we have to calculate mass of displaced water. How to calculate? Okay, for the calculation of mass of displaced water, at first we have to find weight of displaced water and then we will be able to find mass of displaced water. Okay, weight of displaced water. How to find the weight of displaced water? Off thrust is equal to weight of the body in air minus weight of the body in water. This is the off thrust of water, and this is equal to weight in air is 42 Newton and weight in water is 41 Newton. It means off thrust is equal to 1 Newton. And according to the previous information, we know that off thrust is equal to weight of displaced liquid. That's why this 1 Newton is what? Weight of displaced water, I am writing shortly, weight of displaced water is 1 Newton. Now we can use this equation, W equal to mg. Weight of displaced water is 1 Newton. 1 Newton, this is equal to m into g is 9.8 meter per second square. If we take this 9.8 meter per second square to left hand side, an elaborated form of Newton is kg meter per second square, then we'll get 9.8 meter per second square is equal to m, and we cancel this, and 1 divided by 9.8, I want to use calculator, look at this, 1 divided by 9.8, it gives 0.1020. There are other number also, therefore m is equal to 0.1020. 0.1020, we are taking just 2 digits after decimal point, that's why I want to ignore this. Since this number is less than 5, that's why we can remove this, and 0.10 what? Kilogram. 0.10 kilogram means what? 100 gram. The mass of displaced water is 100 gram. Okay, let's have another question. In the given diagram, 3 different bodies having same volume is shown in the liquid. A, B, C, all of them have same volume, but they are lying differently. One is floating, another is sinking, another is suspended. Now question is, compare the density of B and C. What do you think? Density of B and C, we can understand this way. Density of C is greater than density of liquid because it is sinking. But density of B is equal to the density of liquid because it is suspended. If a body sink in the liquid, then its density is greater than liquid. If a body suspend in the liquid, then its density will be equal to the density of the liquid. So looking at this, we can declare that density of C is greater than density of B. That's why we can write the answer this way. What? Density of C is greater than density of B. Now let's have another question. What will be the weight of B in its position? Look at this question is a little tricky. What is this question? Position. In its position, what is the weight of B? In its position, its weight is 0 because weight is downward force and off thrust is acting on it in the upward direction, and both of them are neutralizing each other. That's why the body is suspended in its position. The weight of the body B is 0. Now next, compare the off thrust of the liquid acting on A, B and C. How can we compare? Looking at this figure, don't be confused that A experiences more off thrust because it is floating. No, this is wrong idea. The part of A immersed into the liquid is less, so it experiences less off thrust than B and C. But B and C, all of them have same volume, don't forget this. B and C both have equal volume and both are completely immersed. That's why they displace equal amount of water, and that's why both of them experience same off thrust. B and C experience same off thrust, but A experience less off thrust because volume of the body immersed into the liquid is less. This way we can answer the question. After all this, I want to tell you some equations related to the off thrust which we use to solve numerical problem. There are many equations. Some of them are, number 1, you know about this. This is off thrust is equal to weight of the body in air minus weight of the body in liquid. Using this equation, we can solve numerical problem. Now another, we know that off thrust is equal to, weight of displaced liquid. Weight of displaced liquid. Weight of a body is the product of its mass and acceleration due to gravity. That's why whether it is liquid or solid, weight of this liquid is m into g. Using this equation, we can solve numerical problem. What? of thrust acting on a body is equal to mass of displaced liquid multiplied by acceleration due to gravity. Okay, let's talk a little more about the same. Third, mass means what? Mass is density equal to mass by volume. If it is so, then mass is equal to density into volume. So, in place of mass, we can write dV. And this is another equation, third equation, which can be used to solve the numerical problem. If we have the density of the liquid and volume of the liquid displaced, then we can calculate of thrust acting on that body. Okay, let's have another also. Let's say we have a liquid in this container. This is upper surface of the liquid, and a body is immersed in it this way. The depth of the upper surface of the body from the surface of water or liquid is, let's say, H1, and depth of liquid up to the lower surface of the body is, let's say, H2, isn't it? Now this is actually three-dimensional body. We can make this way also. This is three-dimensional body. It has certain length, certain breadth, and certain height. Length into breadth gives area, and area into height gives volume. That's why this volume can be replaced by using A into H, AHG, isn't it? And look at this H. H means the height of the body. And this can be written as S2 minus S1. S2 minus S1 gives height of the body. That's why density D into A and G is if taken first, then H is S2 minus S1. Therefore, we can use this equation also. What? Fourth equation. So, we can use this equation also to solve the numerical problem of thrust equal to dZA S2 minus S1. Maybe you have given certain diagram, and if this diagram is given and height from the surface to the upper surface of the body is given, and the depth of the liquid from the surface of the liquid to the lower surface of the body is if given, then you can use this formula also. Now next, do you know that when a body is placed in a liquid, then the liquid applies pressure from all the sides? It was taught in previous class. Liquid applies force from all the sides. Liquid applies pressure from all the sides and force also from all the sides. Pressure acting on this side is equal to pressure acting on this side, because both the sides are at the same depth. That's why pressure from this side and pressure from this side is equal. And we know that pressure equal to force by area. Area of these two sides are equal, and if pressure is also equal, area and pressure both are equal, it means force acting on this side is equal to this side. It means force, two forces are acting opposite to each other and their value is equal. So, they cancel each other. In the same way, the force acting from front side and back side also cancel each other. But the pressure acting on this side, P1, and pressure acting from the lower side are not equal, because this lower surface lies at greater depth than that of the upper surface, and pressure of liquid increases with the increase of depth. So, pressure on the lower surface is more, pressure on the upper surface is less. Now we are using the same equation, P equal to F by A. Area of this surface and this surface is equal. Even after being equal area, why pressure is more at the lower surface? Because force acting on the lower surface should be more than force acting on the upper surface. If force acting on the upper surface is taken as F1 and force acting from the lower surface is taken as F2, then the resultant of all these forces is equal to F2 minus F1. And it acts in the vertically upward direction. That's why we can use another equation also of thrust is equal to F2 minus F1. These are the equation which we can use to solve the numerical problem. Today I told you a lot about the off thrust and how to measure off thrust and what factor affects the off thrust and certain numerical problem also, how to solve the numerical problem related to off thrust. Okay, now I want to stop this class. We'll meet in another class with some another matter. Thank you.